Welcome and Happy New Year. I'm Charlie Greenberg, your host and moderator for Digitus Business Demos, and we're back again with the series where we provide live business demos that focus on different digital transformation and platform strategies, and in particular demonstrate different components and products within Software AG's digital business platform. Today, we're talking about predictive analytics and how that technology in the world of IoT can maximize a company's responsiveness and its ability to provide maintenance for remote devices. In just a moment, we'll be hearing from Richard Wagner, Senior Solution Architect, and Luis Ramos, Principal Business Architect. But first, a little bit about Software AG. If you're not familiar with us, we're a 48-year-old organization well known for customer-centric innovation. Software AG is ranked as a leader in many innovative and digital technology categories. We have over 4,300 employees, $1 billion in annual revenue, and we can cite over 70% of the Global 1000 as customers. And those customers include well over 2 million developers at leading organizations who have adopted Software AG products to innovate solutions and build applications. The customers are cross-industry, cross-private and public sectors, and they rely on Software AG to complete their journeys as digital enterprises by using the end-to-end capabilities of the digital business platform. Please keep in mind that following today's presentation and demo, we will provide a Q&A session. So as usual, please use the WebEx Q&A box at the bottom right-hand side of your screen for any questions and comments. And with that, it's my pleasure to introduce Rich Wagner.
Thanks, Charles. I'm Rich Wagner, and it's a pleasure to be speaking to you today about our analytics capability and deploying that to the edge. I think Software AG is in a very unique place with our capability for how both our streaming analytics capability and our Cumulocity IoT platform and how we can stream data to the edge. So what we're going to go through today is we're going to set up a device and show you how to set up the feeds from these devices. It can be, we're going to show some manufacturing equipment today, but it could be medical devices, it could be connected cars, it could be store equipment, it could be a lot of different things for feeds. But we'll show you how to set that device up and how to stream data through there. Then what we're going to do is take some historical data from historians. Most manufacturing equipment, or a lot of manufacturing equipment and devices, have data that they have in their historians, and it's critical to take this information, run through the different machine learning algorithms and create models based on that data. So as the data is streaming through these devices, we can learn from the data and we can apply that. Then we're going to take that, we're going to talk about and show you how we can take these models and deploy those in real time to either a thin or a thick edge. And I'm going to talk about thin and thick edge in just a minute, just so that we're clear on what that is. Then we're going to go through, Luis is going to take you through, he's going to take the model, he's going to deploy it to a gateway, and then he's going to, based on what we're learning from the data going through, he's going to produce alerts and triggers based on that and feed it back to, we're going to demonstrate this in the cloud. But we could also, some of the stuff that he's going to show you is deployed on the gateway, but we're going to stream the data up to the cloud and show that capability. And hopefully what we're going to demonstrate today is how our Software AG's digital business platform can support predictive maintenance and around the different use cases. What I'd like to talk to you about first is a distributed analytics support capability, okay? What makes us, a little bit unique is that with our streaming analytics platform, it creates a very compact machine learning predictive model capability on the edge. What we're going to do today is we're going to take this and deploy it on an IoT gateway, which we would consider to be a thin edge. We also have the capability to deploy out to the asset itself or onto a gateway, or we can have a server inside of the facility. And what we're showing so our platform is kind of neutral. We can go across, we can go very compact and deploy out to the edge, or we can go and put it in the cloud. And so we're going to show you today, we're going to show you deploying to the edge. We're also going to show you how the analytics look on the cloud part of it. And what this chart shows you is that if you go out to, an asset or a device, they have unique capability. Some of them they can have a PLC capability. Some of them have Modbus. Some of them you have to create an agent, put it out there. A lot of them have unique SDKs. And in order to deploy something out on the edge, you have to have deeper knowledge than if you're going to deploy it in the cloud. But the flip side of that is that the availability of that model running on that asset is very high. Whereas if you go over to the cloud, you don't have to be as knowledgeable or as about different devices and SDKs and things like that. However, it's not as available because you have things that you have to worry about, radio or Wi-Fi or cell communication. This is just a kind of a comparison of, things that you would want to deploy on a thin edge versus the thick edge. And so on the right-hand side, you can see where you wouldn't want to put out there on a thin edge, an application integration or things like that. What you'd want out there is you'd want the correlator and the model, and you'd want the data streaming through there. And you might have some edge capability, but it's really a byproduct of what you're going to deploy out there is a byproduct of the edge capability. So what I mean by that, the memory footprint and the physical hardware and what you're going to put down on the thin edge. And because every component has some resource requirement. And so, what we're going to show you is how we're going to deploy a model down on the edge. And then on the thick edge, you can deploy things like, SCADA diagrams and take the feeds. You have more visualization, more analytics capability. Whereas on the thin edge, you can have some analytic capability, but it might not be as visual as on the thick edge. This is just, what we see is, distributed analytics and where you would want to do some machine learning and where you wouldn't want to do it. We can lay out machine learning at almost every layer. What we're going to show you today is where we're going to take the models and deploy them down in the gateway. We're going to take the stream from the devices and basically do the machine learning at the gateway. Now, we can also deploy that same model on-site or in any other regional platform or in a data center or anywhere. The demo today, what we're going to do is we're going to go through, we have an extruder machine on the left-hand side. And so what we have is we have the historical data, and we're going to stream that through. And then Louis is going to show you some replay capability where we have kind of a unique function where we can stream all the data against the model, and then if we don't like what happened, we can change the model and stream it again until we get what we feel we need. So you'll see some of that today. So what we're going to do is we're going to connect up a feed from the extruder machine. We're going to connect that to the edge gateway. We have our streaming analytics platform out on the gateway, and we're going to stream as the events are coming off the devices, we're going to learn from the data that's coming off the device in a model on the gateway, and we're going to stream that using MQTT into the cloud. And then we have dashboards in the cloud, smart rules, alerting, things like that. The one thing that I want to key to this is that we feel that we can deploy this in days, not years. So we have a very fast time to market to connect devices, to deploy the streaming analytics capability of the correlators down on the gateway, and creating this whole predictive analytics capability. Some of the things that you get out of this is that you can predict when we think a device is going to fail. And that's kind of a key thing. So if we have a feeder machine and, the temperature between the, we've learned that temperature variances between the different feeders and the mass flow and the RPMs is different, then what we can do is we can see based on what's happening with that failure why that happened. And so based on, as this is going on in real time, we can take action based on what we're seeing and solve problems before they happen. We can create better support for SLAs, and we can dispatch technicians automatically, and we could automatically order parts. The other thing that we're going to show today is that, if you're having, we're going to push data that is relevant data. A lot of data that's coming through from the edge is the same data over and over and over again. So what we're going to do is we're going to selectively filter what data we push up to the cloud. With that, I'm going to start the demo part of this. And the first part of it, I'm going to show you, this here is a dashboard. And so what we did is we created this is our Cumulocity IoT platform. And what we have here is we have some feeders that are coming off that extruder machine, and this is feeder 1. And these dashboards have all been set up. We have the device set up. And things like that. What I'm going to show you real quickly is how easy it is to set up a device to stream the data and apply the model to. This here is feeder 2, and I have a group set up, but I don't have a device set up. So what I'm going to do is I'm going to create a device called feeder 2 and set up feeds into the device. Now we have guides on, we have a lot of reference device guides for if you're going to hook up a Netcom device or a Dell gateway. We have documentation that tells you how to do that. Today, what I'm going to do is I'm just going to use our REST APIs. Everything that we do, we have MQTT or we have REST APIs that you can do. You can deploy down on a device, and you could communicate up to. You can stream the data through the gateway to the cloud. So what I have here is I have some APIs that I've set up. We have hundreds of APIs. We have an API guide that you can, if you want to send a measurement or get last measurement and things like that, you can use these APIs to interact with our platform. What I'm going to do is you can see here, this is the structure. So this is the schema of the device that I'm going to push in here. The name of it is going to be feeder 2, but it could be anything. So with that, I'm just going to go ahead and do this post. And if I wanted to do a get, I could get that data right back that I have. So now if I go over to my device management platform, it's part of my Cumulosity, and I look through the devices, this shows all the devices that I have connected in my cloud. But I'm interested in the feeder I just created device. And you can see that I have feeder 2 here, and it was just created at 10/16. So what I have here is I have a shelled out device. I'm going to do a couple of things. I'm going to put an interval where I'm expecting information to be flowing through this, and if it doesn't flow through, it'll automatically send alerts. Then I'm going to put it into that group that I had over on that cockpit for feeder 2. And so what that'll do is that'll add that to my dashboard, my cockpit over on the other side. And then I go down and I save these changes, and you can see that the connection has started, and I'm going to, wait for things to come in. If I don't have any transactions within a minute, then an alert will show up and you'll have an alarm go off. So now what I want to do is I want to send a measurement in there so that if I go back to the device, this is the device ID. And go back to the REST API. Oops, let me get that one more time. Okay, and I'll post this measurement over there. And if I go back over here, you see that I had a measurement come through. So now I'm going to go back over to my cockpit. That is how easy it is to connect up a device. And again, we have agents, we have device guides that you can use. And if I go back to my predictive analytics platform, if I go under this, I have a device connected now. The other thing I did is because we set this up so that anytime a feed comes through, it'll automatically create these dashboards just like the one Lewis is going to go through in just a little bit. But what I want to do is show you real quickly how easy it is to, put some dashboard capability in here. So I'm just going to add a new dashboard, and I just call it a demo dashboard. And you see here where it could be applied to these different types of devices. So I could apply this to, and it would automatically apply this dashboard that I'm creating to anything that's has this type. Then I'm going to add a few widgets. Things that are interested to me is I want the alarm list. And so the alarm list is going to be, you can have different severities, and you can create alarms based on different things. What you're going to see when we get further in, when we're deploying the model down on the edge, you're going to see that these alarms are going to be automatically triggered inside the platform. So you can see that I did have an alarm go off because it took me more than a minute to put that measurement in there. The next thing I'm going to do is I'm going to add another widget, and it'll have, and these are different widgets that you can have. You can put graphs, data points, images, things like that. But what I'm is just a data point list. And so the only thing that I've sent so far in that measurement was that set point. And I'll save that, and you can see that that set point now is there. So if I go back over to here and I send another measurement in, go back to the cockpit, you'll see that measurement starts getting fed through to the device. The last thing on the dashboard that I'm going to do is I'm going to add a widget, and I'm going to add some SCADA to it. So I'm going to browse. I have a SCADA diagram that I have. And inside the SCADA itself, it's like a memory variable that you put on the image itself. And so what I'm going to do here is I'm going to map what's on that SCADA device to the last measurement. These are just different capabilities that we have inside the platform, but these are preset: last measurement, device list, event count, things like that. And you can create your own. But I'm just going to do last measurement. And I'm going to have that. And I'm going to have a return point of the value only. And I'll submit it. And so then I have the device now. I have the diagram, the SCADA diagram, and I also have where the value will show up. And I don't like how this is positioned here, so I'm just going to drag it over and move this around. And so, and then you'll see that as measurements come through, it will automatically update that SCADA diagram so you can basically pinpoint like errors and things like that are going on. So that's how easy it is to create a dashboard. So I've created the device, I've created dashboards around the device, and I've set up some alarms, and it's that easy to do that. Now, so we have the dashboard, but what we want to do is we want to deploy the model to the edge. So just to give you a little background on what we've done, is we have our data scientists took a look at the data that we have out of the historians. They give us this data model. As you execute this and you go through there, what it ends up doing is it creates this PMML model. And that PMML model is what we deploy to the gateway and run for runtime, so that you can take the stream off the devices, apply the R model or Python model, or we're very neutral on that, and deploy it down on the edge. So with that, I'm going to hand it over to Louis, and he's going to go through deploying this PMML model on the gateway and streaming the data through the edge.
Good day, everyone. Just check, make sure you see my screen and you can hear me. Oh, okay.
Sounds good.
All right, thank you, Rich. Before I actually show you how we execute models and analytics on the gateway, just step back for a bit to give you some more context so that we're all in a good position to get a good understanding of our technology and how it works on the gateway. So Rich mentioned this extruder. It's producing some metrics, some readings. In particular, it's producing these 4 metrics: the drive command, mass flow, the motor speed, and the set point. And we're streaming that into the gateway box. And the way that we're ingesting that in the gateway box is that through the use of an adapter. In our platform, we support a wide variety of protocols, various adapters in order to ingest all kinds of formats and data. For example, it could be Kafka, it could be JMS, HTTP, REST. But once it's ingested in the adapter, what we do is that we transform that data into a canonical event format. So the format kind of looks like this. It it's a set of a number of fields. We call it a D value, X value, Y value, Z value, and there are others. I'm just showing you the ones that are used in the demo. These are, the D indicates that it's a decimal, the X, Y, and Z are float values. But the process of ingesting the data, I'm not going to cover in today's talk. It's outside the scope of what we had intended to do in this webinar. So I'll leave that to a future webinar to discuss the details of configuring the adapter and so forth. So suffice it to say that as I start to show you the tooling on how we start analyzing this data, just keep in mind that the data consists of these, this flat set of values. Now, internally within the platform, what we do is that, as the data is ingested, we send it to a channel. So we use a channel paradigm within the platform. And behind a channel, you can have listeners, some processing nodes, some analytics that are listening for data that is going to these channels. So for example, in this demo, I defined a channel called data. So every time we send an event to that channel, then there are analytics that start working on it. Okay? So let's look at the map or the data flow, starting from the device all the way through the analytics and through the alerts. Certainly in a lot of development environments, there are specialized teams that create these predictive models, as Rich had mentioned. For the purpose of this demo, we assume that someone had handed us such a model. Now, what do we do with these models? So if we're going to deploy this model, in this platform, we use something called an industry analytics toolkit. It's a way to define and configure any analytics that you want to run or execute in the gateway. And a predictive model is one such analytic. It's a predictive analytic. So we configure that, and I'll show you in a minute how the tooling itself and how you configure it. But just to show you the roadmap in terms of the data flow. So we use this toolkit. We configure. We take that predictive model. We do a bit of configuration, and then there are some other things, some other analytics that you could do as part of that. And then we upload it to Cumulocity. So this generates a configuration file. We refer to this configuration file actually as an event file because our streaming analytics platform is event-driven. But we also upload the model to Cumulocity. And then using Cumulocity, you can deploy that out to the gateway. It's a very nice platform for doing that. You can develop your applications to be able to deploy it to all or a group of gateway devices that you have in the field. You can customize and define commands. So this is general flow. Alternatively, you can bypass the Cumulocity IoT and just deploy it directly to the edge. So you have various ways to deploy, and certainly this is a more direct way to do it. So now let me show you the tooling itself. Yeah, so this is the analytics builder. So this is the tool that we use to define and configure the analytics. And we have a catalog of various analytics that you can use. So this is configuration driven. You never need to write any code. You just basically just drag and drop analytics from that catalog and put it in your palette. And then when you select that analytic, on the right, you'll see a set of configuration parameters that you can set. So what I want to do here is you know, Rich had given me this model and I want to deploy it. But you know what? I don't want to execute this model for every event, for every reading that I get from the device, right? So now I'm going to show you the power of this platform. I want to be smart about when I actually execute the model. And this is actually a practice that we have. So I'm going to introduce some filtering first. So I want to filter the data and only, you know, to weed out the duplicates. And I also want to throttle it. All right, so I have this series of analytics that I'm doing now on the data. So I throttle it first. And actually, I just wanted to show you this tool. It actually shows you the documentation down here based on what you select. After throttling the data and filtering it, then I want to feed it into my prediction module, right? And I want to highlight here the value of doing all this on the edge. By doing the throttling and the filtering on the edge, you're able to avoid, you know, the network overhead, the cost of having to send all your data, all your readings up to the cloud. You know, so that can be expensive, especially if you have readings that come in very fast. You could do all filtering and throttling out on the edge. All right, so based on the output of this sequence, the throttle and the filter, now I want to feed it into the into the prediction. Okay, here it is. And I need to connect, so the feed coming out of the filter, the process feed, goes to a channel, right? So we introduced this paradigm of channel. So it's sent to the channel called filtered, and I just need to match that here to make sure that it gets connected. Okay, and notice that this data, I also introduced the channel that we're sending all the data to, which is here, the one I mentioned earlier. So it's going to the channel. All right, so far I've not written any code. Yeah, and then we can go in and set the configuration here. And for brevity, I'm not going to go through the details of writing each and every one of these parameters. You know, like a cooking show, I have it already here, already set up. The important parameters that you need to configure with a prediction are the input and output parameters. Right? So this module is expecting, the predictive model is expecting some input parameters, and it's expecting 4 of them. And these are the same 4 metrics coming out of that extruder box. And we're defining the, so if you remember this, the D value, X value, Y value, and Z value of, we're mapping those, the incoming parameters into the input fields for the model. And then the model is producing two pieces of data, which is the probability itself. So what this model does, it's doing predictive analytics. It's producing a probability of failure. and a status. So that's coming out here to this other channel called PMML output. Now there are two other things. I'm going to switch back to the version that we were building. So it's producing these predictions. It's producing a more compact or a less volume set of feeds that it's sending out. This is going to be sent out to Cumulosity. Now, there's some other things that I want to do on the edge. For instance, whenever the feed goes down or it stops after a period of time, I want to be able to detect that at the edge. So I have a set of analytics, these detector analytics, missing data. So I'm going to add that to this in the builder. And I'm just going to read it off of the, the original data, or alternatively, I could feed it off of the filtered data, the stream coming off into this channel. And also, the other analytic that I want to do here is to detect spikes. So maybe from experience, I noticed that when there's a spike, say in the motor speed, maybe something is stuck. It could be a spike up or a spike down. It stopped for some reason. Maybe there's something that went through the extruder that forced it to stop. And I want to be able to detect that. Right? So going back to this finished cake, where we've done all the configurations, we now want to push this out to the edge gateway. So by simply saving this, so once I save this, it's going to produce a file, and this file, the intent is to push this to the gateway, but I don't want to do that yet. Like good deployment practice, you want to do some testing and some validation first before you actually deploy it. So what I'm going to do is I save that file into a project. So this is a streaming analytics project. And the file looks like this. I'm just showing you the contents of the file. So these are events, and they're tuples. And these were generated for me by the builder. I want to test this. And fortunately, Rich was able to give me a captured set of data. So this is real data that's been captured, historical data from a historian. Maybe it came from OSIsoft or some other tool. But what I've done is I've taken that data and set it up so that I can replay it. Right? So down here on the lower right, as part of this environment, I can replay the data. So, and I'm going to do that. So as I'm running this project, it's injecting this artifact, and I'm going to replay it. So when I press the play button here, and notice that I'm playing it at 10x speed. If I go back now and look at the cockpit, I see data starting to come in. And every few seconds you see the readings, the motor speed and the mass flow changing. And the trend chart on the left just shows you the motor speed as a Bollinger Band. So it's tracking, it's showing not only the actual value that came in from the test that I was doing, but it's also tracking a moving maximum and a moving minimum and a moving standard deviation. So we'll let that build for a while. And on the right, you see it's also showing the probability of failure, and this is in percentage. it's a very small probability. It's 1% or less, but it's there. Now, the other thing that we set up here are these alarms, right? Remember that we included an analytic to check for, to look for missing data and for spikes. So when the edge box detects those, then it will show up here on the alarm. And I haven't seen an alarm yet, so I'm getting impatient. So what I'm going to do is I'm going to pause the replay, and I'm going to make it run faster, and hopefully we'll get to some data that would result in those spikes. Okay, so I've restarted it now at 100x speed, and hopefully in a minute we'll see some alarms here. So while that's going, the other thing I wanted to show you is what happens if after a couple of days, the data science team said, oh, we have, we started looking at some newer data, we produced a new model. We retrained the model and we generated a new model. And now we want to push that retrain or that updated model to the gateway. So I'm going to show you how that's done. Basically, you go back to the builder, and I'm going to strip this all out. You basically just produce a prediction like this, and you type in maybe it's a new model name or a new PMML file name. So you basically configure it in the usual way. The important thing is this management ID. You have to tag this. Because what we're going to do is that we're going to swap this into the model that's currently running, and the way it knows to replace that is to make sure that you're using the same management ID. And then I wrote I have this script on this box. So I'm on a gateway box now. I wrote this script, update model, and what it does is that it injects the whatever event file was produced from this configuration. I'm going to do that now. So having executed that, it stopped the old model that was running, and then it started executing the new model. Okay. Okay, so here we see an alarm. I just saw that we have an alarm here. It's saying that the motor speed had spiked for feeder 1. So I'm going to clear that. I think that's all that I had intended to show as part of this demo. So let me turn it back to Rich.
I hope that you got something out of the presentation today. What we did is we showed you how to set up a device and create the dashboards, and hopefully you could see that it's fairly easy. We can go from easy, and we can create very elaborate dashboards. It's all based on open standards, everything we do. So, if you want to have your own dashboard, you can do that and sync into the devices. We use data from the historians. We learned from the data and had our data scientists create the model. Handed that model over to Lewis, who deployed it out to the gateway. And then based on what we're learning from the model, we would trigger alerts and actions based on that. And we can go all the way to, updating we didn't show it as part of this demo, but we can update ServiceNow or interface to Salesforce and things like that. So with that, I'm going to turn it back over to Charlie, and thank you very much.
Thank you very much, Rich, and thank you, Louis. And we have some questions, undoubtedly, and we're still accepting questions, so please use the WebEx Q&A box at the bottom right-hand side of the screen to convey any questions or comments. And please also notice that Rich and Louis have provided their contact information just in case something occurs to you once we've gone offline. What kind of configuration or specs does the gateway need to be? Could you talk a little bit about those requirements?
Yes, that's an excellent question. So we are certified with the Dell Edge Gateway devices. There's various models. There's a 5,000 that comes with 2 cores and from 2 to 8 gig. There's another model, a 3002, which is a smaller form, less memory. It's still 2 cores but with 2 gig. We also run on a Raspberry Pi. So it's a very small footprint. You can do that. The platform works very well in that platform. Because the platform is supported on standard operating systems, Windows, Linux, so it's very easy to support in any gateway box.
So along those lines, could you talk a little bit about an implementation time frame and maybe what you actually need to start the process?
Yeah, this is Rich. I'll take that. It depends on the client. What we'd like to do is we like to, we have whole guides around setting this up and implementing this. It can take as, if you just want to stream data from devices, we can do that, in a couple hours, depending on the device. And then if you have models that are already created, we can deploy those really straightforward. I found that takes the longest time is actually getting the data, because all the data, it ends up being a lot of data. And so you have to run it through the models and stuff. But I was even surprised that my data scientists could run through that in a couple of days. And then to set up the infrastructure and stuff, you can set up a gateway, in a day or so, but that's just very optimistic stuff that I'm putting out there. But, my point I'm trying to make is that you can do this in a real short period of time, but, you're going to have some structure, you're going to have some testing that you have to do, and some DevOps things that you have to do. So it will stretch the timeline. But you can get up in a development environment really quickly.
Thank you for that comprehensive answer. Now, does the Software AG streaming analytics solution have the ability to predefine corridors to help identify anomalies, or is a corridor or corridors a parameter that is actually set up by an administrator before the stream of data flows through the solution?
Shall I take that? Yeah.
Yeah.
Yeah. That's it's very flexible. You can set these corridors at design time when you're configuring the analytics. You can make it dynamic. You can set the corridor at deployment time, and it can be set up so that you can change the corridor values at runtime. And more than that, you can even define a specific corridor that is dynamic based on the moving averages and standard deviation. It's very flexible.
Okay. Does the gateway need to be powered with GPU or such for training models?
The gateway. Go ahead.
Go ahead, Rich.
Now, the gateway, you know, there's multiple different gateways. So to say all of them fit one, you know, we're using for this presentation, we're talking about the Dell gateway, and it's just powered like a normal server. But then you know, you have gateways like Netcom gateways, and you know, their requirements are a little bit different. So what we have is we have patterns set up for all the different gateways, where you know, if you need to deploy things on a Netcom device, we have an agent for that. For if you're going to do things on a Dell gateway, we have you know, instructions for how to set that up. So it's not one fits all. There's different capabilities in different gateways.
If we have our own data scientists, can we deploy these models ourselves?
Yeah, the answer is yes. They're easy to deploy. You know, basically what you do is, like, I'll take an example of R. If you have a R set up and you pass me a model that was done in R, I just need to make sure that the libraries that you use are in my environment, and then as I run through it, it'll automatically execute the PMML model for me. Most data scientists, you know, they have, you know, things that they like, but it's very easy to take models that people have and deploy.
Looks like we have one final question, and again, I would state that you can see both Rich's and Lewis's contact information, so if something occurs to you, please reach out, or you can always reach out back to us for the digital business demos, and we'll make sure your question is answered. So finally, I would like to know more about the design time, runtime, and scalability on the edge.
Yeah, let me take that. Yeah, we have done some quite a bit of benchmarking on the Dell Edge gateway devices as part of our certification with Dell. In terms of scalability, the demo that I actually showed you, I benchmarked it. I was running a day's worth of data, you know, something like just a couple hundred readings per second. And the footprint, the memory is about 400 megabytes. But the really interesting thing is that the CPU is barely budging. It's only at 1 or 2% of the CPU, which means there's still a lot of room to process data. The platform is very scalable. You can run multiple servers. We call them correlators. It can scale horizontally as well as vertically.
Our thanks once again to Rich Wagner and Luis Ramos for helping us to understand more about these predictive analytics capabilities and how they apply to maintenance. Please join us next week. We're back to artificial intelligence, also known as machine learning, and as you can see, we have quite a schedule coming up for Q1. So please register now for any of those or all of them. In the meantime, we look forward to seeing you again. Take care.